Okay, so much our challenge 25. We'll be solving various types of inequalities, especially ones that have send them. So let's take a look at this one. We have x plus 6 between 2 and 13. Whenever you see two inequalities here, what we're typically looking at is an interval. Okay, so let's go ahead and solve. I'm going to preserve the integrity of the original problem. So we have 2 less than x plus 6 less than equal to 13. So again, preserve the original problem, right? This is the second time. Then we're going to solve for x in the middle. So we have an adding 6 here. We're going to make subtracting 6. Whatever you do on one side, or I should say, whatever you do on the inside, you do on the outside. So minus 6 here, minus 6 there. So what we end up with is a negative 4 less than x less than or equal to 4 plus 3 is 7. Okay, and this is your set notation solution. Okay, now also we want to get the line segment of the graph, so it'll look like this. There'll be a line segment open at negative 4 and closed at 7. Okay. So that's the graph of what we're looking at. All the numbers between negative 4 and 7, including 7. And the interval notation of this would be parentheses negative 4 to 7 with a bracket indicating we're using 7. Okay, so those are all three of your answers. Number 2. Again, we're going to preserve the integrity of the original problem. So we have 4 less than or equal to 2x minus 8 less than 10. And here, what we're going to do is we want to solve for x. We're going to add 8 to both sides, all sides. So add 8 here, add 8 here, and add 8 here. This will give me 12 less than or equal to 2x, and then less than 18. Okay. Then from there, I'm going to divide all sides by 2. And what we'll get is 6 less than or equal to x less than 9. This is our set notation solution. We also want the graphic solution, which will be a line segment closed at 6 and open at 9. Okay, so it's all the numbers between 6 and 9, including 6. Then there's also the interval notation, which will be bracket 6 to 9 parentheses. Okay, so make sure to write all three of your answers here. Okay, number 3, we're solving for x, and we have a dividing 2 and a subtracting 5. We're going to get rid of the dividing 2 first, so let's preserve the integrity of the original problem. So 1 plus 10, x minus 5, 2 plus 3. So I'm going to multiply everything by 2 because we're dividing 2 here. So we'll get rid of the dividing 2 by multiplying by 2. So there we go. So we're going to distribute our 2 here, here, and there. So 2 times 1 is 2. 2 divided by 2 is 1. And times x minus 5 is x minus 5. And 2 times 3 is 6. Okay. From here, we're going to get rid of the negative 5 by adding 5 to all three sides. And we end up with 7 less than x less than 11. Okay. That's the set notation answer. The line segment that this represents is the line segment between 7 and 11. And it's open at both ends. So it's all the numbers between 7 and 11, not including 7 or 11. The interval notation for this will be parentheses. 7 and 11 parentheses. Okay. Okay, let's take a look at this. Now we're going to be dealing with absolute values. Now, there are absolute values with the x value needs to be on the left side. Remember, for inequalities, the x needs to begin on the left side. So very important that your absolute values that include the x's are on the left side. Secondly, the procedure for removing the absolute values is this. If the absolute value is followed by less than, we're going to basically remove the absolute values. 2x plus 6 is less than 10. Okay, there we go. And then after they're removed, we're going to add to this another less than sign on the other side and the opposite of this value, so negative 10. So when you remove the absolute values, it will look like this, and then you add the new pieces, you'll get this whole thing, which is basically going to become a line segment. So let's solve for x by subtracting 6 from all sides. We'll get negative 16 less than 2x less than 4. And we'll divide all sides by 2. And we end up with negative 8 less than x less than 2. Okay. So this means that the solution for this is any number between negative 8 and 2. So you can choose any number for x that's between negative 8 and 2. Let's say you chose negative 7. 2 times negative 7 will be negative 14, and negative 14 plus 6 will be negative 8. And the absolute value of negative 8 will be positive 8, and positive 8 is less than 10, so that works. Another number that's between negative 8 and 2 will be 1. So x is 1, so 2 times 1 is 2. 2 plus 6 is 8, and the absolute value of 8 is 8, and that's less than 10. So you were getting all the numbers that work for this equation. Furthermore, the graphic of this will be a line segment, all the numbers between negative 8 and 2, not including negative 8 or 2. And finally, the interval notation for this will be parentheses, negative 8 to 2 parentheses. Okay. So write all three of your solutions here. All right, number 5. Number 5, once again, we have an absolute value on the left side followed by a less than. So we're going to remove the absolute values. Okay, there we go. And next, we're going to take the problem that we removed the absolute values, and we're going to repeat this symbol here. So we get less than again, less than or equal to. And then opposite of 12 is negative 12. And now we'll solve this for x. And again, we're going to get a line segment because we have the two inequalities here with x between. So plus 9 on all sides. End up with negative 3 less than or equal to 3x. And that's less than or equal to 21, I believe. Okay. Then we'll divide all three sides by 3. And we end up with negative 1 less than or equal to x less than or equal to 7. Okay. So this means that we can use any number between negative 1 and 7, including negative 1 and 7, in the original problem to solve this. So let's just check that out. So let me put negative 1 actually in here and see if it works. 3 times negative 1 is negative 3. Negative 3 and negative 9 make negative 12. The absolute value of negative 12 is 12. And 12 is less than or equal to 12. So negative 1 actually works. If I put 7 in here, I get 3 times 7, which is 21. And then 21 take away 9, it's going to be 12. The absolute value of 12 is less than or equal to 12. So the outside numbers actually work as well, or in any number in between these. So the graph of this will be a line segment closed on both sides to include -1 and 7 as solutions. And the interval notation for this will be bracket -1 to 7 bracket. So these are your three answers. Okay, now let's take a look at number 6. Number 6 is the inequality, and it's followed by a greater than sign. That's handled much differently than the less than signs. Okay, so how do we handle this? With the greater than signs, we have to split this into two pieces, a left side and a right side. Okay, on the right side, I'm simply going to remove the absolute values. So this will be x plus 6 greater than 5. Okay, so right side, just removing the absolute values, and that's it. On the left side, we're going to take this same answer here, the x plus 6 greater than 5. We'll keep the x plus 6, and we're going to change these two symbols. We're going to flip this to less than, and we're going to change this to a negative. So we actually got two changes over here, no changes over there. And then we're going to solve both of these sides. So let's start with the left side. So subtracting 6 from both sides, I end up with x is less than -11. Over here, when I solve this, I subtract 6 from both sides. I end up with x is greater than -1. And this is actually, we're finished. These are actually the solutions of this. Now, the graph of these would be, let's see, this will be open at -11 and going to the left, or this side right here, which will be open at -1 and going to the right. So this is what the graph looks like. It looks like the graph, the number line with a gap in it, basically. Now the interval notation will look like this: negative infinity, parentheses, negative infinity to -11, parentheses, union with this part right here, which is parentheses, -1 to positive infinity. Okay. So these are your three answers that I'm looking for. Okay, look at number 7. Number 7, we have absolute value of 4x minus 6 greater than or equal to 14. And again, absolute value sign is on the left and it's followed by a greater than sign. This is an indication that we're going to split it into two pieces, a right side and a left side. So let's do it. The right side will simply remove the absolute value. So 4x minus 6 greater than or equal to 14. Okay, that's your right side. Left side, we're going to write the same thing for 4x minus 6. But we're going to change these two symbols. We're going to change that to a less than, and we're going to change that to a -14. Okay. So left side, everything gets turned around. So less than and -14. Okay. Now from there, I'm going to start solving for x on the right side and on the left side. I'll probably start on the left. So plus 6, I get 4x is less than or equal to, let's see, 4 plus 4 is -8. And then divide by 4, I get x is less than or equal to -2. Okay. Over here, I'll add 6 to both sides. I'll get 4x is greater than or equal to 20. And then divide both sides by 4. I'll get x is greater than or equal to 5. Okay. So these are my two answers. X is either less than or equal to -2, or x is greater than or equal to 5. So what does that look like on graph? That's a closed circle at -2 going to the left, and a open circle going to the right of 5. Sorry, closed circle, my fault. It's a closed circle. Okay. And the interval notation for this would be negative infinity to -2 with a bracket, union with bracket 5 to positive infinity, which takes us to the right, parentheses. So make sure you write all three of these solutions. And those are they.